So we're going to try to go through the 8 pages of work. So we'll go through it quickly. All right, so we'll start with the special triangle. So you need to know your exact ratio. So hopefully people can see the screen. If not, you probably have to come closer. So there's a right angle. So this is 45 degrees, 45 degrees, and 1 and 1 and root 2. And the other one is this one, 60 degrees, 30 and right angle. So it will be 1, 2, root 3. So that's on the reference sheet. And then you can use the triangle to fill in the exact ratio table, but you're recommended to memorize the table. So we'll start with this one. This is half. This is 1 over root 2. This is root 3 over 2. And the cos theta is root 3 over 2, 1 on root 2, and half. And the tan ratio is 1 on root 3, 1 and root 3, like that. Now there's a worksheet available. If you didn't get one, you can come to get one at the front desk. Okay, so this is useful when we try to calculate the exact ratios. For example, in this example, sec 210 degrees, you can change that to 1 over cos 210 degrees. And then after that, you have to find what the quadrant it is in. This is in the 3rd quadrant. And then use the ASTC rule to determine the sign. So it's all stations to central. So therefore, in the 3rd quadrant, it is negative. Change that to negative. And then you also have to find the related angle. How do you find the related angle? So this is 210. So to find the related angle, you have to find this angle. So you do 210 minus 180 degrees. That will be 30 degrees. So you write 30 degrees. And that's where you use the table. Cos 30 is root 3 over 2. So you write root 3 over 2 equal to negative 1 over that, which is equal to negative 2 over root 3. All right, any question? Good. All right, there's another one. What if it's a multiple of 90 degrees? If it's a multiple of 90 degrees, instead of using this all stations to central, you should use the graph. So let's draw the graph of sine. So you should memorize the graph. Looks like this. And then from the graph, you can work out this is 180 degrees, so which is 0. Another way to do that is you can use the calculator. Just type in sine 180 degrees. This is in degree mode. Make sure it's in degree mode when you do this. So it's 0. So there's 2 ways: either draw the graph or use the calculator. Good. Okay, that's good. Okay, let's move on to the next question. So how do I draw the cos graph? Memorize the shape. Looks like this. Like that. Yep. Okay, good. So let's move on to the next page. We also need to know how to solve equations. I have summarized all the different types of equations. So whenever cos x or sin x equal to 1 or 0 or negative 1, we should use the graph of cos and sine respectively. If it's tan x equal to 0 or cot x equal to 0, use the identity sign of cos or the graph of tan to solve. Any other equations, make sure you use the related angle and the quadrant approach. So let's follow this procedure. For example, 2 sine x plus 1 is 0. So you make sine x the subject, which is negative half. And then what you do is you look at the quadrant. So it's negative. Which quadrant is negative? Negative in the 3rd and the 4th quadrant. That's your first step. Second step is to draw the ray. I've done this. Find the related angle. How do you find the related angle? Use the calculator to shift sign. Make sure you do positive. 1 over 2. Positive. That's 30 degrees. And once you get the related angle, find the actual angle. So to get the actual angle, you do 180 plus the related angle. Or the other one, 180, 360 minus the related angle. Like this. And then you end up with 210 and 330 degrees. Right, any question? All right, the next one is sin x cos x equal to 1. So you don't use a quadrant approach because whenever you get 1 or 0 or -1, better to draw the graph because it's a boundary angle. So you draw the graph of cos x, which looks like this. And it is at 1 at exactly 0 and 360 degrees. So therefore, the answer will be 0 degrees and 360. So get the idea? All right, good. Now be careful, if it's tan x equal to 1, you don't draw the graph. So these two are different. So tan x equal to 1, you still have to use the quadrant. So you look at the first quadrant and the third quadrant. And then you find the related angle, related. That's equal to tan inverse of 1. And then use your calculator. So shift tan 1. And you will get 45 degrees. And you put 45 there, 45 here. And then you find x. X will be 45 degrees in the first quadrant, or in the third quadrant, you do 180 plus 45. So the answer will be 225 and 45. Good, any question? What if it's 0? Now, if it's 0, you have to, if it's tan x equal to 0, use the fact that tan is sine over cos, and then times both sides by cos x. And then you end up with sine x equal to 0. And then you draw the graph of sine x. And then use that to help you to solve. And then therefore, clearly from the graph will be at 0 and 180 degrees and 360 degrees. So it's very important that you know the graph of sine and cos. So try to memorize it. And this is the solution. All right, good. So we've done the first page, first 2 pages. The next thing we're going to do is to revise all the identities. Some of it are on the reference sheet, but you're advised to memorize all the identities. So let's revise some of these. Okay, reciprocal identities. So these are sec x equal to 1 over cos x, cosec equal to 1 over sin x, and cot x equals to 1 over tan x. And there's the 2 ratio identity. I think that's on the reference sheet. Is that sine over cos is tan, and cos over sine is cot. Like that. And the Pythagorean identity. So just remember Pythagoras theorem that involves squares. So the one that's used a lot is sine squared plus cos squared is 1. And you're recommended to memorize the other 2 that's derived from above. You can make cos squared the subject, or you can make sine squared the subject. So you should memorize these 3 separately. And then the other less well-known is the 1 plus tan squared is sec squared. And 1 plus cos square x equal to cosec square. How do I remember this? Just that the co matches with the co. All right, complementary identities. These are not used a lot, but will be used sometimes. So this one, 90 minus theta, is cos, or cos of the complement equal to sine. So remember, how do I know these 2? Just remember cosine and sine. Co means complement. That's where the co come from. And what else are there? There's the sec and the cosec. And the cosec, 90 minus equal to sec. And we also have cot equal to tan, or tan equal to cot. So you should memorize them. And the best way to memorize them is to write them out many times. And then you have angle of any magnitude identity. So things like this, say sine of 180 minus theta equal to sine theta, and sine of 180 plus theta equal to negative. Just think of this is like a second quadrant. This is like the third. And the fourth will be sine of 360 minus theta is negative sine theta. And the last bit is sine of a negative angle equal to negative sine. And there's similar one for cos and tan. Cos and tan, so there will be a similar one as well. So I'll leave you to check the textbook. Now there is an example just to illustrate the use of the identity formula. So how do I prove this? It's very important that you start with one side. For example, the left-hand side, 3 cos square theta minus 2. And then you look at the right side. The right side says sine square. So it looks like the identity that convert cos square into sine square is this. So use this one to help us. Let me highlight this. So I'm going to replace the cos square by 1 minus sine square theta. And remember to use the bracket. And then if you expand that and collect like terms, you should get the right-hand side, which is the right-hand side. So that's a very typical proof. All right, good. All right, so this is most of the theoretical part. Let's go through some practical aspect, the non-right angle triangle results, such as the cosine rule and the sine rule. So we'll go to the next page. I think these are taught to you. You were taught about this in year 10, so hopefully you know this quite well. So let's go through this very quickly. All right. Yeah. The video? Yeah, I'll record it. Oh, this one again? Oh, yeah. Okay. I mean the whole page, this whole page? Okay. I think it got worse. Too small. All right, leave that on. I'll record a video. I'll put it on YouTube. All right, hopefully you're ready. All right, let's move on. All right, let's move on. I think we're done. All right, quiet please. Okay, so non-right angle triangle. So there are 2 sides and 1 angle included, SAS situation. So what we do is we're going to use the cosine rule. If it's all 3 sides given, we also use the cosine rule. Any other cases, we use the sine rule. Let's write down the formulas. I think all of these are on the reference sheet, but it's always good to memorize them. Area of triangle is half AB sine C. That one. Sine rule to find the sides. A over sine A equal to B over sine B. There's a third one, we don't really use it. And then to find angle sine A over A equal to sine B over B. And the cosine rule to find the side is C squared equal to A squared plus B squared. That looks like a Pythagoras theorem. Extra minus 2AB cos C. And the cosine rule to find the angles will be cos C equal to A squared plus B squared minus C squared over 2AB. All right, we're going to illustrate the use of this formula on the triangle below. So if I want to find the missing side x, what rule do we use? We use the cosine rule. How do we know? SAS. So just remember SAS, use the cosine rule. So you do x squared equals to, which one do you add first? Doesn't matter. So 6 squared plus 8 squared minus 2AB. Cos of the angle. Does that make sense? And then just use your calculator. Make sure it's in degree mode. 143, and then you square root your answer. So 11.98. All right, does that make sense? All right, ready? I use a black pen. I think that would see better. Let's use a black pen. Okay. Next one. All right, what rule do we use? It's S, and then you got the A, but then there's an S there, but it's not SAS. So you use the sine rule. Sine rule. So how do we use the sine rule? If you are finding angles, start with the sine first. Opposite to 4 equals to sine of 80. Opposite to 7. And then you multiply both sides by 4. And then you shift sign to get the answer. And then use your calculator. $34 something degrees. All right, any question? All right, all done. Okay, thank you. Let's move on. Radian and exact ratio. This is chapter 11. So let's quickly revise this. Okay, first one, radian. So you have to memorize these are special angles. So pi is 180 degrees. Oh, so for those who see advanced tuner, I think it's chapter 10. Is it chapter 10? I forgot. Maybe advanced, I think. But anyway, but you know that it's in one of the chapters. Pi is 1 over 180 degrees. That's extension 1. Pi over 3, pi over 4, pi over 6, 3 pi over 2, 2 pi. All good? All right, next one. Let's continue. It's important that you need to know the exact ratio in terms of radian too. For example, sine pi over 6, you should immediately see that that's 30 degrees, so it will be half. So you should memorize this table as well. So sine pi over 6 is half. Sine pi over 4, which is 45, is 1 on root 2. This should be root 3. 1 on root 3, 1. And then that will be root 3 over 2, half. 1 over root 2, root 3 over 2. Okay, any question? Let's go through the next one. This is important. Let's go through sine 5 pi over 4. So how does this work? So what you do is this. There's two ways. Method one is you convert that to degree. So to convert that to degree, you times by 180 over pi. Let's see what we get. So 5 divided by 4 times 180. So you get 225. And then after you do this, you write sine 5 pi over 4 is same as sine of 225. And then just use this previous method that's in the third quadrant. And then you find the related angle, which is 45 degrees. But it's negative in the third quadrant. So sine 45, you know, is negative 1 on root 2. That's one way. Let me show you the other way. Method 2 is to not change to degree, but you work with the radian. This is the preferred way, but some people prefer this method where they just convert to degree. Everything becomes very simple, but I think it takes more time in the long term. Now watch this. If you don't want to change to degree, you can find out where 5 pi over 4 is. So all you need to do is, this is 0 pi, this is half pi for 90, pi for 180, 3 over 2 pi, which is 1.5 pi, and this is 2 pi. So for example, 5 over 4 pi is equal to 1.25. So you know 1.25, it must be here. 1.25. And after you do this, once you located the quadrant, to find the related angle, you follow the same procedure. You do 5 pi over 4 minus the pi to get your related angle. And if you do that, make a common denominator, you get pi over 4. So it's pi over 4. So you write sine of pi over 4, but negative. And then you look at this table. Sine pi over 4 is 1 on root 2. So it can be quicker than the other way. Okay? All right, all ready? Okay, move on to next page. All right, next page. Sketch the graph. Now it's in radian. You do 0, pi over 2, pi, 3 pi over 2, 2 pi. All right, let's continue. So what we do is we're going to draw the graph. It's recording, good. And then for cos is 0, pi over 2, pi, 3 pi over 2, 2 pi. So exactly the same graph, just different angle. One's in radian, one's in degree. And then we're going to solve equation again using radian. So how does radian work? You do exactly the same procedures, but we're going to solve the same equation two different ways. One is using degree. If you were to use the degree, you use the same procedure as before. Find the quadrant. It's in the third, second, and the fourth quadrant. Find the related angle, tan inverse of 1. And then if you do it on a calculator, you will get 45 degrees. Shift tan 1. Oops. Shift tan 1. You get 45 degrees. But because it's in radian, you must change it to radian. But we know this is exact, so you get pi over 4. So you put pi over 4 here. Actually, don't, just keep it as 45. And then what you do is you write 45 there, 45 here. And then to find the angle, you do 180 minus 45 or 360 minus 45. And then you end up with, what would that be? That will be 135 and 315. Now be careful, that's not your final answer. It's important to note that the domain is in radian, so you have to convert to radian. So you have to multiply by pi over 180, pi over 180. And then what do? So use your calculator. So do 135. Yep. 135 over 180. You get 3/4, so you get 3/4 pi. What's the other one? 315, 180. You get 7 pi over 4. Yep. Okay, see you. And the next bit, listen. Shh. This is method 1. Method 2, I'm going to show you. It's exactly the same, but instead of working in degree, we're going to do it in radian. So you do the same thing as before, and you got the tan inverse of 1, which is 45, but straight away you change it back to pi over 4. But instead of 45, you put pi over 4 instead. Right? And then you write x equal, instead of 180, you do pi minus pi over 4. And the other one you do 2 pi minus pi over 4. And then you can make them the same denominator. So that will be equal to 3 pi over 4. The other one you do 8 pi over 4 minus pi over 4, 7 pi on 4. So you get exactly the same, but I think it's quicker with method 2. But some of you may prefer to work with degree because it's easier to do, and that's okay as well. But make sure you convert your answer to degree. But the disadvantage of that is, if you have 4 answers, you have to make 4 conversions, whereas this one's more direct. Any question? Now on the next page, there's some practice question. Can you please have a try? There's answers at the bottom for you to check. So go to next page, there's for you to practice. Can start now. And on the last page, there's extra question you can do in your book. All right, so that's trigonometry in a nutshell. So make sure you do your own revision. I will put the video up in a link. I will send you all your emails so you can watch the video later if needed. So do this, and then there's this one you can do as practice. Answers all provided. Let me just do one question. For last one, okay, I'll do the last one. How does this work? Negative in the second and the third quadrant. What's the related angle? Related cos inverse 1 on root 2. But if you remember the exact ratio, that's 45 degrees, which is pi over 4. So put pi over 4, pi over 4. And to get t, you do pi minus pi over 4 or pi plus pi over 4. And then you end up with 3 pi over 4. It's like 1 minus a quarter or 1 plus a quarter. And if I check the answer, I've got it right. Any question? All right, make sure you do your own revision. I'll stop the video. You can watch it later. Thank you. And then stay for the next one, for the extension one with Mr. Wong. Thank you.